All right, so we're going to look at your homework assignment, and we're going to use it as practice, or at least as guidance on the basic principles. In this particular problem, we go through normal distribution. We don't have a lot of time. We have barely 25 minutes to go, but that doesn't matter. So I'm going to share screen and show you the problem. Okay, so you see the problem, okay? And it says you use the MS Excel processor to calculate the average price per square foot for houses in the two neighborhoods, okay? And then to also calculate the standard deviation of the average price per square foot, again, in two neighborhoods. So at least two reasons that you think that the average price of houses, the average price per square foot in one neighborhood will be different from the other neighborhood, okay? And then for each neighborhood, establish a 98% confidence interval for the average price per square foot. So we're going to, calculate the average price per square foot for one of the neighborhoods. And then I will provide insight on how to interpret the results, because we're going to now interpret those results in the next week. But I'll give you an insight now so that you understand why we calculate the confidence interval for two neighborhoods and why we can use it to contrast, compare one neighborhood to another, okay? So, so I'm going to calculate average price per square foot, one neighborhood. We're going to calculate the standard deviation for the average price per square foot, and then we're going to do confidence intervals. Now, that, in a sense, we're putting together, three things. One is how to calculate confidence intervals, and then how to make meaning out of the confidence intervals. So based on your results, do you have any reason to believe that the average price per square foot is significantly higher than the average price per square foot in the other neighborhood? All right?
Yes.
Okay. Well, it has to be based on statistical result. This is why I ask students to come to these office hours, because very often I see answers that, are not correct, because we still do not understand the meaning of statistical analysis. When you're doing statistical analysis, you do not, use your intuition. You can say, for example, suppose you didn't have this statistical analysis level of confidence interval estimation, then you can use your intuition and to really answer a different question based on your results. Now, your interpretation must be based on the calculation that you made, not on your intuition why the average price per square foot is different from the average price per square foot. No, neighborhood. Now, aside from confidence interval and the statistical result, yes, you can have a reason. You can have any number of reasons why the average price per square foot could be different from the other. But you are asked to interpret it in light of the numbers. That is the point we are trying to get across here. So let me bring this down. Okay, let's then look at the Excel file. So this is the Excel file, all right? We are asked to calculate the average price per square foot. So I'm going to calculate the average price per square foot for one neighborhood. Let me see. Okay. You can see it clearly now, okay? So this is the average price per square foot, and I will calculate it for our share. Okay. So we are going to H41. All right. So we're going to go equals average H2, H41. Okay, so that is the average price per square foot. Okay, average. Okay. And this, then we'll calculate the standard deviation. Okay. Here we have the neighborhood. All right. Equals S P dev dot S P U H41.
It's missing a parenthesis.
Yes, it's not in the parentheses. The typo. Yes, T dev H. Excuse me. I'm just making the typos. Okay. So here you have the standard deviation. Okay. All right. So we do the same thing for the other neighborhood, which is from 42 to 90. Okay. 42 to 90. I'm going to play a little trick here. Two. All right. And this is our share. And what did you know about the neighborhood? It's Brooklyn. All right. So now we have the average and the standard deviation. So you can see it's very simple. You can just copy this and put it on MS Word file. All right. And copy this and put it on an MS Word file. And it's very easy. So now the next thing then we were asked is to, I'm going to copy this, and then when I pull up the MS Word file, we will have it there. Okay. So I'm going to start this here and pull up MS Word. Okay. So now we have information that we need for a confidence interval. So now let's use this opportunity then to talk about confidence intervals. Okay. So what is a confidence interval? The confidence interval is the starting point for doing inferential statistics. And inferential statistics, you use information from a sample to make inferences about the characteristic of a population. Okay. Now the sample is a selection from within a population. And so an inference is like you're making a judgment. Based on this sample, this is what the population would look like. So in inferential statistics, in confidence interval estimation, you ask yourself, what is the problem? What is the problem that we are trying to solve using confidence interval? Okay. What is the problem we are trying to solve using confidence interval? Now, the problem we are trying to solve using confidence interval, are you still seeing my screen?
Yes.
Okay. This is the problem. In statistical analysis, like you said, you have a population, but you don't know what this population looks like. And one of the characteristics of a population that we want to find out is the mean, a measure of the central position of a particular variable. Okay?
Mm-hmm.
Say the average. What is the average income of professors? What is the average travel time of students that come to school on any day? Now, the population you would be thinking about is the population of all students that came to school on that day. But in order to get that kind of information, you will need to identify every student that came to school on that day. And that is going to be time consuming, that's going to be tedious, that might be impossible to determine because populations are not easy to determine. So because you don't have that information, every single student that came to school, let's say you go into a classroom and see 25 students. Good. So you have a sample of 25 students. And since these 25 students come from the population of students that came to school, then you can say, I'm going to use information from this sample to make an inference about all the students that came to school, to make a judgment about the population of students. And so what you do then is you use this information, and I'm going to write things down for myself, All right. All right.
Yes.
So and then we have a sample size. Let me think about the sample size. Went from 2 to 41. So that's a sample size of 40. Okay. Now, we're still dealing with a large population. So for now, I'm going to make it simple. So now the whole thing then is to ask ourselves, and since we don't have time, we may not go through all of it, but this is why I would urge everybody to be here next week, because I'm going to start getting very strict on solutions to problems. All right. So what we then ask ourselves is, we don't know the true population average. That is why we do confidence intervals. We don't know the true population average, but we're going to use the sample information to estimate what the average could have been or could be like, okay? And so when you do this estimate, there's a low value and a high value. So we don't know the true population average, and the true population average is mu, okay? And I'm going to the true population is mu. Let me see if I can find it. Oh. Yeah. The true population is mu. That's what we'll call it, okay? So this is equal to the true population average, okay? This is the true population average.
Mm-hmm.
We don't know what it is, okay? We don't know what this true population average is, but we're going to use the sample mean X bar, okay? So I'm going to reduce the size of this since you have seen it. Okay, so we're going to use the sample mean X bar to estimate the true population average. I'm going to try to find it. Okay, they don't have it here, but we'll call it X bar. Okay. All right, that's an X with a bar on top of it.
Yes.
Okay. I might be able to get it here. Okay, I'm going to do it another way, but I really want to explain it to you. All right, this is now freezing on me. So X bar, as we see here, is the sample mean. So we calculate this X bar, and then we use this information from the sample mean, which is what we have here as 293.7.
Mm-hmm.
And we use this information to estimate what the true mean is. And so what we do then, we say to ourselves, what is the formula? Okay, the formula will then be the formula that we derive from statistical, from mathematical statistics, which we're not going to go through here. But we have a sample size of 40. Sample size n equals 40. And so we do a calculation, and I'm going to put together that formula and see if I can put it together for you. Okay, so we have the formula X bar minus Z times sigma over the square root of n. Okay, it's less than or equal to mu less than x bar plus z times sigma divided by the square root of n. Okay, so what you see there as pi is actually n. All right, okay. Let me see if we can change it. Okay. All right. So now this is the formula that we're going to use. Now, incidentally, I have to go to another officer, but I want to make this very clear to you. So
Yes.
my question is, are you going to be free like tomorrow evening and we can now solve this problem through?
I can try. It's just
Okay.
my work schedule
Okay.
definitely.
All right. So this is what we could do then. I'm
Yeah.
going to have another office hour in the next 10 minutes, actually in the next 6 minutes, on the same topic.
Okay.
Uh,
I can do
so,
that.
okay, so then I'm going to send you the link so that you can join there.
All right. Thank you so much.
All right. So we'll solve through this problem and you can see exactly where we're going with it. But
Yes.
let me see, maybe we have a little time. We have the information here, okay? But the point is that we haven't talked about Z, okay?
Yeah, we
Z,
have.
yeah, Z is the normal distribution, okay? And when we
Mm,
do a confidence interval, we do a confidence interval at a certain level, like a 98% confidence interval or a 99% confidence interval. So
mhm,
in that way, we we say to ourselves, we don't know what the true mean is. However, with a 98% confidence or a 99% confidence, we can say that the true mean is between this lower value or this upper value. That is X bar, this 297, minus the result of the calculation here,
mhm.
which is the lower value, or X bar X bar plus the calculation Z times sigma over the square root of n. We can we can do that. I mean, once we have that information, we say, you see that the true mean is in the middle here. All
Mhm.
right. So the true mean is between this lower value on the left and the upper value on the right. And we can say that with 99% confidence or with 98% confidence, or we can even say with 90% confidence. When you say it's with 90% confidence, that means there's a 10% chance you're going to be wrong. If you say with 99% confidence, that means there's a 1% chance you could be wrong, okay? But you can never be 100% confident that your mean is going to be between here and there. No. And what I have not explained to you is, what is the level of confidence? Let us try a 99% confidence, okay?
Yeah.
Okay. So we say 99% confidence interval. Okay. So a 99% confidence interval, then in that case, we have to choose a Z that gives us a 99% confidence interval. And that Z value, I know off my head, is 2.576 or 2.58. You know, you can say you can use 2.57 or 2.58. Okay, but the true exact value of that Z, the proper Z to use for this calculation would have been 2.58. And so you take 297 minus in bracket 2.58 times sigma over root n, which will be 118 over root square root of 40. But I have to be off in a few minutes. And so what I'm going to do, I think I can look up your email address.
I can put it in the chat here.
Oh, yeah, okay, put it in the chat, then I'm going to use it.
Yes.
Okay? And I'll send you the link for the next meeting.
Yes. Let me
All
send
right.
Yes, let me send that to you now.
Okay. Did you send it?
It's gonna send now.
Okay.
Sent it.
Okay. Okay. Okay, I see.
Mm-hmm.
Okay, so I'm going to send you the link for the next meeting, all right?
Okay,
So,
thank you so much.
all right then. So to see you there.
Yes.